Hi everybody, so I wanted to go over quiz 1.4. This was the first quiz that included a FRQ, and we'll spend some particular time noting that because on the upcoming assessment there will be some FRQ questions. Um, and in general as a class you tended to struggle a little bit more on that. And I think with a little explanation, I think that you can go into the assessment feeling pretty confident. So, the first question here in this quiz asked about the molecular structure of lineolic acid and palmitic acid, which are two substances shown here. Based on the structures, which molecule is more likely to be solid at room temperature? This is just testing sort of your understanding of the monomers and the chemistry of fatty acids and lipids. Palmitic acid is more likely to be a solid because of fewer carbon-carbon um, because of the absence of the carbon-carbon double bonds, which allows them to pack together a little bit more tightly, which causes them to excuse me. They pack together more tightly. They are less likely to move around. That reduced movement leads to being solid phase at a higher temperature. Or at room temperature. You should understand, like, for all the major macromolecules, the basic shapes, functions, and behaviors of the molecule. Okay, question 2. This one was the written response, and there were 3 parts to it. So, let's see if it's going to give me the... No. Okay. That's fine. So the diagram shows water molecules as solid at 0 degrees Celsius and liquid at 25 degrees Celsius, and it asked you to do a few things with that information. So first, describe why hydrogen's bonds form between water molecules. So to get full credit on this question, you needed to discuss the concept of polarity within an individual water molecule. You needed to identify that the polarity comes from unequal sharing of electrons between oxygen and hydrogen in their covalent bond due to oxygen's higher electronegativity. The polarity then creates a charge difference, and the charge difference leads to an attraction between the molecules. That is all the stuff you should understand about it. And when it asks to explain why hydrogen bonds form, you should probably go ahead and put that all in there. At the very least, you need to talk about polarity between water molecules, that oxygen has a slightly negative charge and hydrogen has a slightly positive charge, and that positive and negative charges attract to each other. Okay? It's really important that you don't misdescribe the bonds, that you don't describe what is a hydrogen bond as a covalent bond, or the bond between oxygen and hydrogen in a water molecule as being a hydrogen bond. It's not. So it's all about carefully using the language of this unit. Part B, explain why the arrangement of water molecules is different in ice and water. Now, some of you just gave too simple of an answer here. You said something like ice is less dense than water, which doesn't explain why the arrangement is. Some of you did talk about how water, liquid water, has more energy, and so the bonds are breaking and reforming. Whereas solid water has less, but actually several of you in this case said that when water molecules slow down as they become ice, they actually pack together more tightly, which is true for most things that are going from a liquid to a solid, but it's not true for water. So when water forms a solid, the hydrogen bonds create a crystal-like structure with more open space between the water molecules than they have when they are liquid. and those hydrogen bonds are breaking and reforming. And as they break and then reform, the water can actually pack a bit more tightly together in its liquid phase than it can in its solid phase. So the explanation has to do with hydrogen bonding, creating a crystal lattice structure that puts the water molecules farther apart from each other in the solid form than in the liquid form, where there's more energy and they're moving more freely. A lot of you did not earn credit for that one. And you should go back and review your response to that one. Question C, this one was, you were supposed to draw. I didn't give most people credit for this because I think I only had one student who was creative enough to cut this image out and then draw on it and then insert it. Actually, I gave them credit for it. But the way you would have needed to do this is you would have needed to look at the surface of the water, use a single water molecule in the template, and draw arrows representing the possible location of hydrogen bonds formed by the molecule. And you needed to do it to explain surface tension. The possible hydrogen bonds formed by a water molecule below the surface are shown, right? So at the surface, you would have shown a back and forth arrow between this water molecule and this water molecule, and between this water molecule and this water molecule, because they could bond this way with the hydrogen attaching to the oxygen, or this way with the hydrogen attaching to the oxygen, and then a single direction arrow to the water molecules adjacent below them. Okay, so arrows only at the surface would have been the correct way to do that. Part D, the arrangement of water molecules in ice causes it to float. Explain how ice floating on the surface of a body of water affects the water in a way that is beneficial to the organisms in it. Now, in addition to understanding how water behaves and creates the emergent properties of water, like surface tension and the fact that ice floats and so on, cohesion, adhesion, you need to explain why they're beneficial. Like, what ways do living things use this? And that's what this is asking you to do. Explain how it affects the water in a way that is beneficial. So some of you simply said ice is less dense when it's a solid, so it floats on top of the water. Great, that's true, but it doesn't explain how it's beneficial. So you got to read the question carefully. In the case of ice, when it floats to the surface. At the surface, that ice creates an insulative blanket. Remember, waters has a very high specific heat, so it's able to insulate, right? So hot things cool down slowly, cold things warm up slowly. So the ice itself is cold, so the warmer water underneath resists changing back into liquid water, and the cold air above the ice, it resists turning the liquid water underneath into a solid. And what ends up happening is the water underneath the ice is insulated. So essentially it doesn't change temperature, remaining liquid all winter. Now, why does that benefit organisms? Well, living things in lakes or bodies of water that are frozen need to be able to move through liquid water, obtaining oxygen and nutrients, and they need the liquid water to survive. So if ice didn't float, if it sunk, if it got more dense when it froze, you would have essentially a lake that a layer would freeze at the top from the cold air, that layer would sink, and then another layer would freeze and it would sink, and another layer would freeze and it would sink, and eventually the entire lake from the bottom to the surface would be frozen solid. This way, the ice at the surface insulates the water below, keeping it in its liquid form, which allows life to live. Most life can't survive inside of frozen water. So, that was a long explanation, but be prepared for some FRQ questions on Thursday's assessment, and let me know if you have questions.